I was asked what is the difference between relative risk and odds ratio. And both are measures of association between two variables. And I'm going to give an example of the simplest case, which is the association between two dichotomous variables, so two categorical variables with two categories each. And let's suppose that we have a variable that is exposure. I'm going to represent it here in this 2x2 table. Another variable that is disease status, and both these variables have two categories, no, yes, so exposed and unexposed. And actually, let me write it like this: non-exposed and exposed, and the disease status is going to be disease and non-disease. Okay, and let's assume I'm going to make up an example here that we have among individuals that have been exposed. You can think about an exposure, I don't know, something like smoking or drinking coffee. Exposed, let's say that we have 100 individuals that have been exposed, and among these 100 individuals, there are 70 individuals that developed disease. Okay, so we have 30 that did not develop disease. And in this cohort of individuals, we have, let's say, 900 that haven't been exposed. And from these 900, we have 100 that developed disease and 800 that did not develop disease. Okay, so to explain the difference between relative risk and odds ratio, it's important to understand what's the difference between probability and odds, because the relative risk is going to be a ratio of two probabilities, while the odds ratio is going to be the ratio of two odds. And odds and probability are two different ways of measuring uncertainty. Okay, so I think it's better to give this as an example. Let's say among the exposures, or among the exposed individuals, the risk of developing the disease, according to this data, or the probability of developing the disease. So I'm going to write the probability of disease given, this is vertical bar, that individual has been exposed, can be estimated from this 2x2 table as 70 individuals that developed the disease of a total of 100. Okay, so 70 individuals out of 100, so this is 70%. Very well. We could do the same thing, let's say, for the non-exposed individuals, non-exposure, and you should be able to calculate now the probability of the disease among the non-exposed is, as you guessed, 100 individuals out of 900 individuals, right? So 100 individuals developed disease out of 900 that did not develop the disease. So this would be 100 out of 900, and this is roughly, let's see if 100 divided by 900, this is 0.0111. Let's round it to 0.11. Okay, now the odds, as I said, it's a different measure of probability. The odds of disease among the exposed individuals is going to be estimated from this data as 70. So 70 individuals that developed the disease among the exposed ones. But now, instead of dividing by the total number of exposed individuals, I'm going to divide by the individual that did not develop the disease. So it's 70 individuals that developed the disease divided by not developing the disease. So 70 over 30. Okay, and as you can see here, the odds, contrary to the probabilities, can be higher than 1. Probabilities, as you know, are bounded by 0 and 1. Odds are bounded between 0 and then plus infinite. So in this case, the odds of disease for the exposed one is going to be 2.33. 0.3333. I'm going to round it like this. Okay? So as you see, it's another way of quantifying the uncertainty of developing the disease in the exposed group, but in a different way of a probability. And the odds of disease among the non-exposed, you guessed it right, is going to be 100 of individuals who have the disease divided by 800 that did not develop the disease. Okay, so, and this is going to be so 100 divided by 800, 0.125. Okay, so you see these are different measures, again, of uncertainty. An easier example to see the difference between odds and probability: in a fair coin, the odds of getting a heads in the coin is, as you know, 0.5. The odds of getting a head in a fair coin is 1, because it is having a head versus not having a head. So it's 1 over 1. Okay, 1 chance over 1 chance. So now the relative risk is going to be defined as the ratio of the two risks, this one over this one. Okay, so 0.7 divided by 0.11, and that gives 0.7 divided by 0.11, 6. I'm going to round it, 6.4. The odds ratio on the other side is going, on the other hand, is going to be the ratio of these two values. So 2.33 divided by 0.125, and this is 2.33 divided by 125. It's going to be rounded 18.6. Okay, so the way to interpret these two values, so the risk ratio or the relative risk, you can say that the probability of someone developing the disease among the exposed group is 6.4 times higher than in the non-exposed group. Okay, while for the odds ratio, the odds of developing the disease in the exposed group is 18.6 times higher than the developing disease in non-exposed group. Okay, I hope I did not make any mistake. I don't think so. So these are two, as I said, two ways of quantifying the association between these two variables. Now, when the disease is rare among the total number of individuals, in this case we had 170 individuals with disease and 830. So when these values gets very small, the odds ratio and the relative risk are very similar. They tend to be very similar. Okay, but in any case, there are two different measures. So why do we talk about these two different measures? Well, you can think about as the same case as mean and medians. They serve slightly different purpose, and the biggest advantage of odds ratio is the invariance property of the odds ratio, which I'm not going to explain here now, but basically, if you have a case control design, you cannot directly compute relative risks, but you can compute odds ratio. So the odds ratio is a valid measure of association between the two variables in a case control design, but relative risk it's not. Okay, while in a cohort study, let's say if you have a cohort of individuals that you follow over time, it's valid to compute both the relative risk and odds ratio, and we usually opt to compute the relative risk, maybe just because we are more accustomed to interpret relative risk. Okay, so just a final note: relative risk and odds ratio are both measures for the same purpose, but their interpretation is quite different. One is a ratio of probabilities, and the other one is a ratio of odds. Okay, I hope this was sufficiently clear.